right, 2.2, applications using linear inequalities. Now, applications mean word problems. I like that they don't word that as real-world linear inequalities, because, again, what's a good application? What's a good real-world problem? I mean, that's a personal thing, right? And we all have different experiences. So you may have to read these several times. That's a key point here. I think I've said this about word-type problems. Sometimes you have to read these several times. I've had students say, hey, Sal, I had to read that like 10 or 12 times before I really understood. Yeah, I don't really know what to do about that, but it may take that type of dedication before you really start to understand what it's asking and what information is given and how you're going to use that information to solve the problem, okay? In that case, that's a schema thing, right? If you come in and you're like, dude, I already know how to do that problem, you have the schema for it. If you don't, then yeah, you might have to read it several times before it makes a good connection for you, all right? But applications. So I got to translate the following into a verbal statement. Some other basic vocabulary, right? Sum is addition, difference is subtraction, product is multiplication, quotient would indicate some kind of division here, okay? Another word for multiplication is times, which we see right here. So we'll use x for our variable. That's nice. But here's the statement. The sum of 3 times a number and the number is greater than 9. So what is this? It's a sum. That's the first thing I notice here. So that's addition. What are we adding? Well, we got to add 3 times the number first. So that's 3 times x. And the other part of the sum. And the other part of the sum here is the number. So that's another x right there. Is one of the key words. There's equals. Oh, that's usually equals. It says greater than, so I'll have to use a symbol for that one. If I can get this to work. There's a greater than. So let's get rid of that equal sign then, because it's not an equality. It's greater than, right? So again, for me, I'd say the less than sign looks like a L. Greater sign, again, with a little swoop, you can make that G. But it's greater than 9. So here's my 9er. 3x plus x is greater than 9. And this would be our translation right there. That is one of the boxes you're going to have to fill in on the homework for a problem like this one. But now we're just going to solve this like we would from last time. And we're looking to combine any like terms. I got these 3 x's and this 1x right there, which would combine to be 4 x's, which is now greater than 9. I'll try to use the same colors. And then we'll divide both sides by the coefficient to make it a coefficient of phantom 1. So x now is greater than, well, 9/4. Okay, and that would be the second part of the solution there. It didn't ask us to graph, which, I don't know, I think that's kind of nice right now, but that would be the 2 boxes you got to fill in right there. Your goal is to find a job that provides an income of at least, okay, there's our inequality, of at least $42,000 a year. Emma's Furniture offers you a job paying a base salary of $20,000 a year, plus a commission of 6.5% of his sales, or of your sales, I guess. Determine what your total sales will need to be for you to have a yearly income greater than or equal to $42,000. So a couple things to identify on this one, all right? We have the goal. Okay, so the goal, we want that to be greater than or equal to, so we are comparing this to, well, I guess that is kind of the goal. The goal has to be greater than or equal to this $42,000. Okay, so this is, I don't know, you could say that the $42,000 is the goal. But we want the goal. The goal is to get something bigger than that, or equal to would be fine. But what's included with our goal right here? Well, you got the base salary, so we'll put this in. Base salary. Right, and how much is the base salary? It says $20,000. Okay, and again, I have that down. I read it. Again, if you need to read that a couple times to see that, then do it, all right? But then, in addition to that, you get that commission, right? Hopefully I can spell commission right. I had to cheat a little bit. Now, the commission is 6.5% of the sales, okay? Now, we can't just say it's 6.5%. We definitely can't say 6.5 right here, all right? Because, first of all, it's a percent, and so we're going to need to show that percent as a decimal first. So let's change that just a little bit. That's moving the decimal 2 places to the left, so that'd be 0.065. But again, I can't just leave, it's not a standalone value. It's a percent of what you would be selling. Okay, so that's where we get the unknown in this as X. Okay, so I'm going to define X here. X is the amount of sales. I'll kind of take a little bit of a shortcut here, and there's our sales. Okay. Now, if you add those two together, that would essentially be how you're going to obtain this goal, which should be greater than or equal to $42,000. All right, so you just take the percent, you multiply it by the amount of sales, boom, you get your commissions. And then you add that to the base salary, and then you get however much you would make on the year. So this is the inequality, by the way. And another thing to keep in mind with the second type of problems we're going to be looking at, these types of word problems, it's not going to ask for the inequality. So if you're worried about which side things have to be in, does it have to be in a certain order? No, it doesn't have to be. It just has to get you the correct answer, all right? So that's all we're going to do now. Let's go ahead and solve this. I can make it small enough, and we'll keep that inequality. So first thing first, and by the way, some of you, I think, would probably solve this without actually writing the inequality. If you could do that, do it, because like I said, the inequality is not required. And some students prefer to do it that way, so do it, okay? So first thing I do on this one is isolate my x's, so I'd have to subtract $20,000 from both sides. Right, we're just practicing principles of equality. That's going to zero that out just like we want, and we're left with this 0.065x needs to be greater than or equal to. Now, subtracting that 20,000 gives us 22,000. So what this means, just to interpret what we just did right there, that means that from your commissions, you need to get more or equal to $22,000 just from your commissions. How likely is that in a furniture store? I don't know. I've never worked in a furniture store. Okay, but that's kind of what we're looking at for our commissions. Last thing is to, well, just divide both sides by the coefficient 0.065 on both sides, and dividing that by this decimal value is going to make that sales amount, that number, bigger. I guess I should go to my calculator because I definitely can't do that in my head. So 22,000 divided by 0.065. Enter. Oh, it is a big number. 338,461, and I got 0.538. I'm going to round that to 0.54. So you can put the comma there if you like. You can even show the dollar sign if you like. But that becomes $338,461.54. I don't know this by experience, but I've been told that there's, pieces of furniture out there that cost that for one piece. I don't know where that is, but that's what someone told me. So, I'm sorry. But that's your goal. That's your goal for sales amount, right? Now, some of you may be wondering, well, how did we know the X was going to be sales without knowing that it's 6.5% times the sales? Well, if you read the problem, again, this just comes with some of the reading. It said your X value should, whatever your variable is, should be what you're trying to solve for, right? And it said determine what your total sales will need to be. If you can see that in the words, then automatically that should be your X value because that's what you're going to need to solve for, all right? Do keep in mind that it was the question here too, be for you to have a year, it's asking for greater than or equal to. That means that this is the minimum amount that you need to sell at this place. So that's the only part it's going to ask for right there. It's not even asking you to write the inequality there in the end. I don't know. I think that's kind of convenient. There we go. Victoria needs to rent a car while on vacation. Rental company charges $25.65 plus 23 cents for each mile driven. If Victoria only has $62 to spend on the rental car, what is the maximum number of miles she can drive? Well, we'll round that to the nearest mile, which I suppose could be convenient. Try this one out. Take a minute, try it out, and we'll go over it. But again, showing that inequality is not a requirement because on the homework it's not going to ask you for it, all right? But here we go. So We got, let's see, I don't know what to call it, like charges. We got charges compared to, let's put has. That's dollars, by the way, dollars that Victoria has, okay? Because that's what we got to compare. I don't know, maybe the final cost would have been better. Whatever, charges and has, okay? But here's what we know is that she can't spend more than she has, okay? So the cost, the charges, whatever we know, whatever we have, it needs to be less than, it could be equal to how much she has, right? Because if she goes over the amount that she has, then, well, she doesn't have enough money. Again, it could be equal, and that'd be fine. So, what are the charges? Well, we got, we'll call this a rental. I'm going to call it a rental fee. I'm just going to call it a fee, actually, so I don't have to write so much. But that's $25.65. But then, in addition to that, we're going to add the mileage charge. So, mileage. I think I spelled that right. The mileage charge, okay? Well, how much does it cost in mileage? Well, we don't actually know the final cost, but what we do know is that it's 23 cents for every mile. Well, remember, this one is asking what is the maximum number of miles she can drive. So that has to be our X anyway. So X equals the number of miles. You can put miles driven if you want, but I'm okay with just keeping it simple like this. So if you take the mileage and multiply it by the number of miles she drives, that would tell you how much she will be charged just for the mileage. We need to add those two together to figure out how much the total charge or cost would be. Well, how much does she have or have had, whatever. It says $62, right? So there's how much she has, $62. Do be careful again on this. A common mistake here is where we see the 23 cents shown as just 23. But if we compare the fees and the amount she has in dollars, then we need to keep this one in dollars as well, okay? And that's I know there's a slight deception there. I don't think that's on purpose. It's more, I mean, you should be able to pay attention and see that it's 23 cents. Definitely not 23 miles, $23 per mile, right? Not that all of these are always that applicable, but now we are ready to solve this inequality. So, first thing we would do, and just like I said, some of you probably did this part in your head, you'd say subtract the $25.65 from both sides. Some of you said subtract $25.65 from $62. And then this tells you how much she would have just for the mileage, right? Now when I put this in the calculator, what did I get? $36.35. So again, that is for 23 cents per mile. Okay, so that's our mileage. That's all the money she will have left for the mileage from the $62. But now we need to figure out how many miles she can drive, so that would be dividing both sides by the coefficient 0.23. All right, now here's the thing. I'm going to show at least a couple decimal places from when I got on the calculator. 158.043, I guess I'll round it to the fourth decimal place, not that it matters. It did say to round to the nearest mile, and some of you say, well, you're going to round down. Well, look, if this was a 9 right here, what would the answer be? It'd still be 158. Because the moment that she goes 158, excuse me, more than 158 miles, no matter what that decimal is, the company's going to charge you for that extra mile. Maybe that's too real world, but you can't go above 158 no matter what that decimal is. So even though it's not a 9, it's a 0, and you'd say, well, we're going to round that down. That's true, but it wouldn't matter what that is. The final amount of miles she can go on this car is 158 miles. Is that a lot? I don't know. Seems like not very many miles, though. If Victoria wanted to, she could just drive 10 miles. I mean, I don't know what she's driving here for. Vacation, right? That doesn't seem like very many miles for vacation, but yeah, she could if she wanted to. Hey, drive 110 miles, you know. And so that's where maybe thinking about that a little bit more in the end would come in handy. It's like, well, that 158 miles, I know that's where the end is, but is that a minimum or is it a maximum? And once you realize that this is a maximum amount, even the wording says it, then yeah, she'd have to drive something less than this. Of course, she could drive it equal, but something less than that. If you thought about this in interval notation, because if you graph this, some people would say, hey, look, this goes all the way to negative infinity and then stops at 158. Well, the problem with that is that, well, I guess that'd be a square bracket, wouldn't it? The problem with that is that you can't drive negative miles. Like they're not going to pay you for driving backwards or anything like that. So that's where you got to be careful on that. I mean, if you wanted to, so you could technically drive 0 miles if you wanted to, but definitely not in the negatives. Again, that perhaps is more applicable than it needs to be, but I do hope it answers the question. A student has scores of 65, 72, and 95 on his first 3 tests. He needs an average of at least 80 to earn a grade of a B in the class. What is the minimum score that the student needs on the 4th test to ensure a B? I kind of joke around about this because, I mean, in this class we have homework and quizzes and stuff. But I know in another class they're like, if you got the 4 tests and that's like it, right? So this is kind of how it works. Well, let's set up the inequality, which, by the way, again, not everyone needs the inequality to solve this, and that would be fine if you did or did not. So let's look at the scores, right? You got the first test score as 65. The next one, boom, 72. Next, 95. What we don't know is the 4th test score, right? And that's the one we're looking for. So I'm going to say X is the 4th test score. I'll just put 4th score, not 4 score. But X is the 4th score. And since we know that the average needs to be 80, so we're comparing this with 80, if we were to take these and add them together, which, by the way, still wouldn't be a comparison with 80, because you'd say, well, we want this to be greater than, it could be equal to 80, right? This is not a complete inequality because it's an average, which means that you're going to have to take all 4 of those scores and divide it by 4, all right? So an average is where you take the sum of values, and then you divide it by the number of numbers. That's a lowercase n, by the way. So in this case, we had 4 test scores. So we add them all together. That's the sum of the 4 test scores divided by 4. That's going to give us the average. We want this average, and it did say average, by the way. We now have this set up to solve, okay? And there's a couple of different ways you can start this. I mean, I guess by the order of operations, I'd say you'd probably add those 3 numbers together first. But instinctively, actually, for me, I would want to get rid of that fraction because fractions destroy lives. And so I'd say, on this one, I'm going to go ahead and multiply this side by 4. But if I do it to one side, I have to do it to the other side. See that? So that's going to take away that divide by 4 right there, right? And now, this may look a little bit sloppy, but it should work. And we still have that greater than or equal to. But 80 times 4, for me, I just do 8 times 4, which is 32, and then tack on the 0. Now, what does this tell us? Because the nice thing about these word problems is you can interpret it as you go. That means that the 4 test scores, if you want an average of 80, it can be 320 points. I mean, it could be 400, right? Assuming that these are out of 100, even though it didn't tell us. But the 4 scores need to add up to 320 points. Well, now we will go ahead and add those 3 scores together, right? So, well, what the heck? I'll do the work here on the left. 65. I'm going to stack them, all 3 of them, and then add, which your calculator would do for you, but I don't know. I just feel like I should. So in the ones place value, 5 plus 2 plus 5 is 12. Carry the 1. 1 plus 6 plus 7 plus 9 should be 23. Boom, there you go, 232. So as of right now, the student has 232 points with 1 test to take. So that's where we get the plus X right there. And that needs to be greater than or equal to the 320 points. I do need more space. Well, one stepper at this point, yeah, just take those 3 test scores that we have already summed up, and let's go and subtract them from both sides. Minus 3, 232. That zeroes that out just like we want. X now is greater than or equal to 90, nope. I better. So this final inequality tells us you can get an 88 on this 4th test, and you have that B average, which is apparently an 80. Or you could get more and still have, again, it's that at least part of it. Maybe I should have highlighted that in green because that was the inequality we had right there. Maggie is trying to qualify for the local bowling championship. To qualify, a person must bowl 5 games and have a combined average score, there's our average again, of at least 175. In the first 4 games, Maggie's scores were 171, 179, 160, and 186. If I remember, I had a perfect score in bowling is 300. I don't think that's actually applicable here because it does say what is the minimum score that Maggie must bowl in her 5th game to qualify for the local bowling championship. So, and again, that's nice to know. We don't need to really compare this with 300 because it gave us the average up here at 175 points, right? So, I mean, maybe the maximum is 1,000. Maybe it's 2 million. It doesn't really matter. We just want that average to be 175, and we have at least 4 scores as of right now. So we're going to take the 4 scores. Game 1, 171. Come on. There's a 171. Game 2, 179. Game 3, 160. And then in the 4th game, you're going to get that 186 right there. So these are the first 4 games. Well, you remember up here it said that she's going to bowl for 5 games, right? So that's where the 5th game comes in. We don't know that score. So I'm gonna write that up here. I'm going to define my X. It's the 5th game. Now it's just that the average has to be 175, right? So I'm going to take these, all 5 of these values. Let's go and add them together. Now by adding them together, that will be the sum. But the average would be to divide that by however many numbers there are, which is 5. And then if we want to write this as an inequality, not that we necessarily have to because in the homework it's only going to ask for this score, that X value. But if she wants to be in this championship, right, she could bowl equal to the average, which would have been 175. That's the lowest average, but it could have been more. So I'm going to show this as greater than or equal to that 175. Now, in that last example, I multiplied both sides by the denominator. I'm not going to do that this time. I'm actually going to combine all of the values that I have right here, which when I do, I get that 696 right there. Now, the rest of it still remains. So I'm going to need to take that value, add X, and then divide by 5. Now, at this point, I will multiply both sides by 5 because I do want to get rid of that denominator right there. And this will kind of tell us the overall score that you would need to have an average of 175 after 5 games, right? 175 times 5. That's what that's going to tell us. If the lowest score she can get for all 5 games as a sum would be 875 points right there, right? And what that does is it kind of gets rid of that 5 right there, but we're still left with the numerator. So we get 696 plus X, and yeah, it's still greater than or equal to 875. And then the final thing I need to do here is to subtract 696 from both sides. And this will tell me the lowest score that Maggie can get on this 5th game right here. So 875 minus 696. When I put that in the calculator, I get a 179. Now, of course, this is just a mathematical problem. It's saying, well, that's the lowest score she can get. And you could even label that as a score right there. But it's the lowest score, right? So if she scores above that, she'll still qualify for the championship. And even at this point, you could say, well, what are the chances she's going to bowl at 179? Well, the 4 games she's bowled, one of those was a 179 or more. So maybe it's a 50% chance. It's kind of a higher score, so maybe some of you would give her a lower percent chance. None of that really matters, but it may be something that you would want to think about if this was what they call a real-life example, right?